All right, now we're into a much more interesting one. Here we're supposed to evaluate this fraction, absolute value of x minus 1 over x minus 1. And I think the most straightforward way of going about this is to use our rule that I showed you, is that the absolute value of x minus a is just x minus a if x is greater than or equal to a, and it's minus x minus a if x is less than a. It's a little squished there. So what I really want to do is I want to break this down into two separate fractions, a plus for x greater than, in this case, our a is 1, and a minus, which x is less than 1, and then we're going to take a quick look, and you see that if we stick x equals 1 into here, if we do that, if we stick x equals 1, we get a 1 minus 1, which is an unhappy 0 on the bottom. So we know that this thing cannot exist at x equals 1 already. Okay? So let's take a look at both of these halves. If x is greater than 1, then absolute value of x minus 1 is simply x minus 1. And it's easiest to see if I put my binomials in parentheses so that I can treat it like a chunk. Okay? So now this is a fraction where the top is identical to the bottom. And if the top is identical to the bottom of a fraction, that means the entire fraction is equal to 1. So if x is greater than 1, this whole thing is equal to 1. Okay. But what happens if x is less than 1? Okay. If x is less than 1, then we're in the minus x minus 1 part. Okay? So now this can be treated as, since I have a negative on the top and I don't have a negative on the bottom, this entire thing can be treated as negative of x minus 1 over x minus 1. And now this fraction again is a 1, but only it has a negative in front of it, so this whole entire thing is negative 1. This allows us to write this fraction, absolute value of x minus 1 over x minus 1, as a much simpler object that is now defined differently in these two regions. It is 1 anytime x is greater than 1. It is negative 1 anytime x is less than 1. And if x is equal to 1, it doesn't exist because we have that 0 on the bottom. And we're done.